guys. Happy Wednesday. For math today, we're going to be doing some review over adding and subtracting our fractions and equivalent fractions and simplifying, because tomorrow you guys have a test. Your test will be on Schoology. There are 12 problems, and you will have to show your work because it is not mental math. So go ahead and get your math notebook and label it at the top. Review for test. As we're going through some problems, ladies and gentlemen, I have the test right here. Okay, I'm going to be going over problems that are specific to your test. You need to make sure you're working with us, not just sitting, being an active participant. If you are struggling with any of these questions, those are the ones that you need to practice tonight. If you have questions, let me know so we can go over them so you're ready to go for your test tomorrow. All right, number 1. I want you to give me 2 fractions that are equivalent to 3/18. In your math notebook, number 1, give me 2 equivalent fractions. Raise your hand if you're still working on number 1. All right, 1 more minute. Leah, will you close our door, please? Not just 1 that is equivalent, we need 2. I heard some friends say they had 1. Turn to a neighbor and tell them at least 1 equivalent fraction that you have. All right, so equivalent fractions, that word equivalent means what? Mimi, that word equivalent means what? Yeah, the same. I need two fractions that would have the same value. Okay? Equivalent fractions, we can try and make this number smaller or bigger with having the same value. What kind of computation could I do, Mason, to give me a fraction that would be bigger but still equivalent? So bigger numbers but still equivalent.
You could do multiplication.
Good. And what would you multiply both of these by?
2.
2. Yeah, I would pick a small number. Okay? You have to multiply them both by the same number. I would not pick big numbers because you're just going to make more work for yourself. So one equivalent fraction would be, what's 3 times 2?
6.
What's 18 times 2?
36.
Okay, so there's one equivalent fraction. Do I have to multiply by 2?
No.
No. Can I multiply them both by 3?
Yeah, that's
That would be another one. What's 3 times 3?
9.
What's 18 times 3?
54.
There's another equivalent fraction. Now, could I see if I could make this fraction smaller numbers and still equivalent? What kind of computation, Raina?
Division.
And what could I divide them both by?
3.
Yes, it has to be something that evenly can go into them. What is 3 divided by 3?
1.
18 divided by 3?
6.
There is another equivalent fractions. And ladies and gentlemen, there are more. I cannot get another equivalent fraction that would have smaller numbers and be equivalent, but I can keep going larger. You can multiply by 4, multiply by 5, and so on. All right, make sure this is in your math notebook. Number 2. I want you to give me this number in simplest form. Number 2. All right, simplest form. I want to simplify this fraction. Okay? How am I going to simplify this fraction? Mason?
Division.
And what can I divide them both by?
9.
Could I do, why not 8? Could I divide them both evenly by 8?
Yeah.
Would 8 work?
Yeah. Wait. No.
No. It has to be something they both could be divided by. So what is 63 divided by 9?
9, 7. Yeah, 7.
What's 70 divided by 9?
9. It's not 9.
This is what you guys told me?
It's not 9. Because 9 times 9 equals 81. That's not
Uh-oh.
6.
Math facts.
It's not 6. It's not 9.
Ladies and gentlemen, these are 3rd grade math facts. What is 63 divided by 9?
7.
What is 70 divided by 9?
9. No, it's not 9. 8.
It doesn't work. Very good. Ladies and gentlemen, we've got to know our math facts. So did 9 work? I could divide them both evenly by 9?
No.
No. So that didn't work. Raina,
Divided by 7. Yeah.
what's 63 divided by 7?
9.
What's 70 divided by 7?
10.
Does that work?
Yes.
Are our math facts correct?
Yes.
Yes. Ladies and gentlemen, we've got to get those math facts. They are really hurting us. Number 3.
Oh, I was like an inch off.
We are going to be finding an LCM. What does LCM stand for? Hannah, what's LCM stand for? Least common multiple. I want you to find the LCM of 7 and 6. Now, remember, on your homework, though, they're not going to have, or on your test, I mean, they're just going to say, find the LCM of 7 and 6. Okay? But you should write them out, then, as a list. All right, let's go through them. Of 7, ready? 7.
14. 21.
Let's stop for now. Remember, we want to do about 3 or 4 and then stop and check. So for 6,
6. 12. 18.
do I have any LCM yet for these?
No.
No, so I have to keep going. All right, after what comes after 21?
28. 32. 42. Wait. No.
28 and then 32?
35.
35. Let's stop there and let's keep checking. 6, 12, 18.
24. 36. 40. 42.
Do I have one yet?
No.
Okay, 7, 14, 21, 28, 35.
42.
Do I have one now?
Yeah.
So what is my LCM of 7 and 6?
42.
42. You can circle them. Least common multiple. Good. Math facts still. All right. Number 4. I want you to find me a common denominator here. 4 4/5 and 3/8. Find me the common denominator. For 4/5 and 3/8. my common denominator here?
Do 5
So I look at my denominators, 5 and 8. Okay, so I need to go ahead and make my list of my multiples, right?
Yes.
All right, so of 5, ready?
5, 10, 15, 20,
Okay.
25,
8,
16, 24, 32, 40.
let's keep going with our 5s then.
25, 30, 35, 40.
Do I have one?
Yes.
What is it?
40.
40. So my common denominator for these two fractions would be 40. Very nice. Number 5. You're going to find me the sum of 7/8 and 1/24. Think about what that word sum means. All right, number 5 here, finding the sum. What does it mean, finding the sum? I need to do what kind of computation, Charlie? Adding. I want to first look at my what? Denominators. Are they like?
No.
No. Can I add them without them being like? No. So let's make a list of multiples. 8, 16.
24.
Oh, do we already know?
Yeah.
What is?
24.
Very nice. And this one already is what?
24.
That works out perfect. How do I make this 8 now into a 24?
3
Times it by 3, and we have a jealous sibling here, this 7. It also wants to multiply by 3. Let's rewrite our new fraction. What's 7 times 3?
21.
8 times 3.
24.
And then I'm adding. What do I do with my numerators?
Wait.
What do I do with my denominators? Am I done? Why am I not done? Simplify. How can I simplify this fraction, Megan? Ladies and gentlemen, on the test, if you give me this answer, you are going to get it wrong. You must simplify. Okay? All right, number 6. I want you to add all 3 fractions. Now, ladies and gentlemen, I would not recommend adding all 3 at once. I would recommend doing 2 at a time. So just add these 2 first. When you get that answer, then add your last fraction. It's what I would do. Raise your hand if you're still working. Okay. All right, let's check. So when I'm looking at my first two fractions, I need to look at their denominators. Do they have the same? No. No, so I need to make a list of multiples. Who can already see what my LCM is going to be? Yeah, 9. Because here, 3, 6, 9. Ladies and gentlemen, I don't mind if you can start recognizing and seeing them. You don't need to make your multiples of 9 then, okay? All right, well this one already is a 9. Do I need to do anything? Nope, so I know I have 1/9 plus, this one's not a 9 though. How do I make that 3 into a 9? Times it by 3. And when I do the bottom, I have to also do the top. Let's rewrite that new fraction. What's 1 times 3?
3.
What's 3 times 3?
9.
Perfect. And when I add them,
4.
my denominators stay the
Same.
Am I done?
No.
I need to bring down what? My denominators, are they like?
Yes.
So do I need to change those?
No.
I can just add my
Numerators.
numerators, and then my denominator stays the
Same.
Am I done?
No.
No.
Why am I not done?
You have to simplify.
I need to simplify. What can I divide those both by to simplify?
3.
To get
2/3.
2/3.
Yes.
Nice job. Number 7, we're going to have one that has order of operations in it because it has those parentheses. We know when we see parentheses that we do those first. Make sure you guys are looking at your symbol because here I have a subtraction symbol. Here I have an addition symbol. Math notebook, go ahead and be working on that one. All right, let's check. I know some of you are still working. That's okay. Work with us then. Can I subtract these
No.
right now? No, because they do not have like
Denominators.
denominators. So when you look at this, 9, 18, what's going to be my common denominator?
18.
18, yeah. And this one already is 18. So I know I already have 12/18 minus, how do I make this 9 into an 18?
Multiple.
Times 2. Would I do the bottom? I have to do the top. Let's rewrite that new fraction. 5 times 2 is
10.
9 times 2 is
18.
All right, let's subtract here. What is 12 minus 10?
2.
And then my denominator stays the
Same.
Okay. Ladies and gentlemen, don't simplify yet. I would just leave it. Okay? If you do, that's okay. You just don't have to. So this is kind of your preference here. If you simplify this one, you would get
7, 9.
what?
What?
If you multiply them both by 2, divide them both by 2.
1,
1 9. Okay? So you could work with 2/18 here, or you could work with 1/9. You would get the same final end answer. But we know our last step here is that we need to add 4 6. So let's work with the 2/18, just because that's what I'm picking. 2/18 plus 4 6. Do they have like denominators?
No.
No. Can anybody recognize what it's going to be?
3.
What's my denominator going to be? 18. And this one already is a 18. How do I change this one to be 18?
Times 3.
So my new fraction there, 2/18 plus 12/18.
14/18.
Am I done?
No.
You need to simplify. I'm not going to simplify that one. You can finish and simplify it. All right, last one. Number 8. All right, there was a green snake that is 8/9 yards long. So there was a green snake, and it was 8/9 yard long. There was a garter snake that was 13/8 yard long. Some big snakes. They want to know how much longer is the green snake than the garter snake. So this one's our green. This one's our garter. They want to know how much longer the green snake is than the garter. What would be your computation to see how much longer this is?
Subtraction.
Subtraction. And what are you going to subtract?
16 and 13, 8 minus 13, 18 minus 8, 9. Yeah.
They want to know how much longer the green snake is than the garter snake. Ladies and gentlemen, don't be confused because these numbers are bigger. Think about a pie. Just because these numbers are bigger doesn't mean that that value is bigger. This one has 8/9 filled in. This isn't exact. I'm just giving you a quick demonstration. This is where it has almost all of them filled in. This one has 13/18. It has a couple more open. Okay? Just because these are bigger numbers doesn't mean bigger value in fraction. 8/9 is almost the whole thing, right?
Yeah.
So which snake is bigger here?
8/9.
Our green snake. So how much bigger, how much longer is our green snake than our garter snake? What's going to be your equation?
8, 9.
8/9.
13, 18. Yeah.
Ladies and gentlemen, I'm not going to finish that for you, but you can go ahead and finish that on your own time. All right, test tomorrow. Let me know if you guys have any questions. All right.